All right, these are our notes on motion and speed. On your motion foldable, you're going to want to start on your first tab. Please feel free at any point during this video, if the notes are going a little bit too fast, to pause and make sure that you get everything written down. So, the first thing that we want to ask ourselves is Boise a big or a small place to live? And then think about it and kind of explain your opinion. So maybe take a second, pause the video, and talk with your table group. Okay, hopefully you were able to talk with your table group and you were able to discuss whether or not you think Boise is a big or a small place to live. And I think the answer to this question depends on your point of view or your perspective. So if you are coming from McCall or Idaho City, Boise is probably going to seem like a pretty large place. Whereas if you're coming from Seattle or LA, Boise might be considered a pretty small place. And so what you see depends on your point of view. All right, so again, on that motion foldable, so this is to try to show you to represent those tabs on your motion foldable. So we're going to be on that first tab there. So the first thing that you want to write down is, what is a reference point? A reference point is a place or object used for comparison to determine if something is in motion. What's the best location for determining how fast something is moving? Well, if you're in a moving car, you want to make sure that something that is not moving is what you're using. So we're going to say that outside the object in motion with a point of reference that is not in motion. If I'm driving and I want to figure out how fast I'm going, I'm not going to look at another car right next to me. I might look at a tree outside because that is not in motion and it is a point of reference because it is stable. So the definition of motion is when an object changes place or position. And to describe motion, you need the following: a start and an end position, movement relative to something, how far something went, and then in what direction did it go. An example is a hot air balloon moving in relation to the mountain. So for example here, right, a hot air balloon moving in relation to the mountain. So at this point, I would like for you to pause, and I would like for you to make sure that you have all of this information down and that you've drawn a picture of something in motion. If you can't think of anything, go ahead and draw the balloons and showing the hot air balloons in reference to the mountain. Okay, now that you are done writing your motion notes, go ahead and flip your tab onto the speed notes. So our speed notes is that next tab, and the definition of speed is the distance an object travels in a certain amount of time. Our units for speed are meters per second, feet per minute, or miles per hour. Really anything that is the amount of time, right? Something that's traveled over the amount of time. So distance over time is really our speed definition. That's also going to be our formula. So our formula is average speed equals distance over time. The really cool thing that you are going to learn in this class is this magical, what we call a power triangle. So in this equation, speed is distance over time. We're going to set it up using our power triangle. So speed is down here, distance is up here, and time is right here. And so anytime we're going north and south, if you will, up and over this straight line, the horizontal line, we're going to divide. Anytime we're going across, we're going to multiply. And so we can use this power triangle to help us manipulate the variables in this equation. So, first example, it says, suppose you ran 2 kilometers in 10 minutes. What is your speed? So take a second and write down this practice problem because that will help you. So write down this practice problem. Once you've written this down, what I'm going to do is show you how I would recommend that you are using some critical reading skills to help you with word problems in this class. So the first thing that we want to do is just identify what we're solving for. And so that's going to be speed. So in this case here, we're solving for speed. Then I'm going to identify the other things in my problem and what those represent in terms of the variables. So my 2 kilometers represents distance, and my 10 minutes represents time. So I have all 3 of my variables here. Speed is what I am trying to find. So when I do that, I have my equation, and it looks something like this. Speed equals distance over time. So if we go to the power triangle, what we can do is if I cover that S up, I can see that now I have distance divided by time is my formula that I should be using. So then, once you do that and you plug in or substitute, just like we did in our cube lab, our density cube lab, you can substitute those values in, you should have 2 kilometers over 10 minutes. I really encourage you to make sure that even in writing out your work, you're using your units in your work. That will really help you report the correct units. So to get that level 4 mastery advanced score, you want to make sure you're showing your work at all possible times, including your units in that is huge. So then once you solve for that, your final answer is 0.2 kilometers per minute is my speed. So again, distance over time. All right, go ahead and take a second and write the next question down. Now that you've written that question down, let's kind of dissect it. So a swimmer can swim at a speed of 325 meters per minute for 6 minutes. What distance will she cover in that time? So we're going to identify that we are solving for distance, right? So if I'm solving for distance, I'm going to go over here and I'm going to cover that D up in my power triangle. So I see that I'm left with speed times time. So that's what my formula should look like. Then I'm going to identify the other variables in my word problem here. Speed is 325 meters per minute, so that's my S, and then T is 6 minutes. So I've got all of my variables and I know I'm solving for distance. I'm going to set my work up, so I'm showing 325 meters per minute times by 6 minutes. That 1 minute is right there just so that we're showing you how we can multiply our fractions, but don't worry too much about that one. So 325 meters per minute times by 6 minutes, that is going to give us 1,950 meters. This is a little bit of a typo. We really shouldn't have this here, and here's why. Let me show you. So in our work here, if I am using my units in my showing my work and setting up my problem, here's how you can make this work. So again, apologies on this typo right here, that shouldn't be there. So if I'm setting it up here, here's my speed, right, meters per minute times by time, 6 minutes. What we look at here is we can cross this value out and this value out, and so I am now left with meters as my final unit. And so because I'm left with meters as my final unit, that's what I would report here. And then you can kind of double check with yourself, because you can look and see, is meters what I'm asking for? Meters measures distance, and that's a check mark. So hopefully that made sense. Sorry about that slight typo in the slides. So a couple of definitions to get down here before we move forward. So you want to know that constant speed is when you are traveling at the same rate of speed, such as 55 miles an hour, constantly on a highway. Average speed is taking the total distance traveled and dividing by the total time. And then finally, instantaneous or actual speed is just the speed at any one given point in time. So go ahead and pause the video, make sure that you have down all of those definitions. Okay, now that you're back, what I want you to do is flip to the very last tab on your Motion Foldable, and we're going to draw in 2 of our graphs today. The first graph you're going to draw, you want to title Speed, so it's going to be our speed graph. Time is on the x-axis, distance is on the y-axis, and you're going to draw it like this. So it's just showing you that here is a constant speed, and then here is showing that while your time is going forward, you are not changing distance. And so constant speed, the object or the person has stopped for an amount of time, and then it's increasing that constant, or it's starting that constant speed again. So here's our graph for speed. And then the next graph that you're going to write down is your graph for average speed. So this is just, again, time is on your x-axis, distance is on your y-axis. So this average speed is showing that you've got a relative average speed no matter how fast and how much time has elapsed. So average speed here on this graph. So once you've got those 2 graphs written in and you've got your motion and your speed notes completed, you're going to work on your motion and speed calculations in your notebook. A key is posted online and it's also posted in the classroom. Don't hesitate to reach out if you have any questions.